In this example, you're asked to verify that secant x plus tangent x all over sine x is equal to cosecant x over secant x minus tangent x. Now, in this problem, I don't feel strongly that one side is more complicated than the other side. In my opinion, I guess the right-hand side might be considered slightly more complicated only because the left side has sine on the bottom. And I always feel like sine and cosine are the simpler trig functions, since all the other trig functions, secant, tangent, cosecant, cotangent, can all be written in terms of sine and cosine. You could certainly prove this identity starting on either the left side or the right side. I think I'm going to start this one on the right-hand side. Like I said, one reason is because there are no sines or cosines on the right-hand side, where there is just sine on the bottom of the left-hand side. But another reason I'm choosing the right-hand side is just because in my other examples, I always start with the left side. So just to show you that these identities can be proven in many ways. So I'm going to start just by copying down the right side here. So cosecant over secant x minus tangent x. And I'd probably start this one the way I start the proofs of a lot of these identities, by rewriting this in terms of sines and cosines. So cosecant is equal to 1 over sine. Secant is equal to 1 over cosine x. And tangent is equal to sine x over cosine x. Okay, and again, in this example in particular, there are a lot of ways to handle this problem. What I might do now is I would note that, okay, from where I am right here, I have two separate terms, but I know that I want to end up with a single term in the denominator. So I might also note, okay, well, I've already got a common denominator here in the denominator of this big fraction, so why don't I go ahead and combine them, since I know I want to end up with a single term there. So let me try that. So I'm going to leave the numerator alone for now and rewrite the denominator. It's got that common denominator of cosine, so I can write it as a single fraction with 1 minus sine x in the numerator there. Okay, and instead of dividing these fractions, I could bring this fraction out from the bottom and flip it over. So instead of dividing by this, multiply by the reciprocal. So I'm going to write this now. Again, I'm leaving the numerator alone, times the reciprocal of the denominator. So put cosine on top and 1 minus sine x on the bottom. All right, and I'll go ahead and multiply that straight across. So 1 times cosine over sine times 1 minus sine. Okay, and let me get a new page here. Okay, so I'm going to have to rewrite where we left off here. Okay, and remember that the goal, so we're trying to work our way to the left-hand side, which was the left-hand side of that equation. We're trying to transform it into this. Secant x plus tangent x all over sine x. All right, so this is what we want over here. Okay, so this is not an easy problem. I mean, at this step, we're a little bit, might be feeling a little bit, I can't think of the word, discouraged, perhaps. All right, so here's one thing you can do when you're stuck. Try, when you have expressions like this one, the 1 minus sine x, multiplied by the conjugate 1 plus sine x. The reason that might help is because it might bring you to one of those Pythagorean identities. So just 1 minus sine x by itself, that's not really anything. But 1 minus sine squared x, that could turn into cosine squared, and maybe then we'd make some kind of progress. All right, but 1 minus sine squared x, that's not equal to 1 minus sine x, but it is equal to 1 minus sine x times 1 plus sine x. So that's where multiplying by the conjugate becomes, you know, a potential idea, something that could potentially help here. So I'm going to go ahead and give that a shot. Like I said, this is a tougher problem, and so we're trying, you know, whatever tools we have in the toolbox, we're throwing at this one. Okay, so let's see, what can we do now? I'm going to leave the numerator alone. In this denominator, okay, so there's the sine x that was already there, and then this, which we know is equal to this. 1 minus sine x times 1 plus sine x is equal to 1 minus sine squared x, which is equal to cosine squared. Okay, well, and now we've got that common factor of cosine. We can reduce that. So let's see what we're looking at now. 1 plus sine x over sine x. And we take another glance at what I wanted. Oops, there's a cosine down here. Forgot about that remaining power of cosine. Okay, so then glance back up here once again at what we want, at our goal. Okay, so notice, okay, we've already got the sine here, and the cosine will actually come in handy. Let's look at this another way. Okay, so I'm seeing what needs to be done. I'm trying to motivate it for you guys. So you know that secant equal to 1 over cosine. We have a 1 here right now. Tangent is equal to sine over cosine. We have sine right now. So what might be a good idea is to divide top and bottom by cosine. If I have this over cosine and this over cosine, I'm going to get this to match. So what if so divide top and bottom by cosine. Another way to put that is multiply top and bottom by 1 over cosine x. So I'm going to distribute a 1 over cosine x to both parts of that numerator. If I multiply, I have to multiply by the same quantity in the denominator, so I'm not changing this ratio. And if I do that, that's going to cancel the cosines on the bottom, which actually does us a favor because we wanted just sine on the bottom. Okay, and I think we've made it. So now, notice, 1 over cosine times 1, well, so that would be 1 over cosine. Sine x times 1 over cosine would be sine over cosine. And this is all over sine. And hooray, that's equal to, well, 1 over cosine, that's equal to secant. This is where it really pays off if you know those trig identities by heart very well. Sine over cosine, that's tangent, all over sine. And that is definitely a tougher identity to prove. I didn't necessarily do it the most efficient way here, but I wanted to show you that there are a lot of different approaches. And just don't give up as you work your steps through trying to verify an identity. Just keep trying to push from where you are. Just think about, okay, how can I rewrite this step where I am now? And keep glancing at your finish line here. Keep an eye on where you want to actually land.